Some examples of finding Taylor series. We're going to use e to the x, and I'm going to do it at different centers. Generally speaking, when we write a Taylor series, we want to get enough terms so we can start seeing a pattern so that we can write our general nth term for the series. So if I start with saying that, well, f of x is e to the x, then I need to know for my first term what f of 0 is. If I plug 0 into that, I get it to 1. So the first term of my series is 1. For the second term, I need to know f prime of x, which, well, it's going to be e to the x, and f prime of 0 there, because the 0 is where we're centered at, is 1. So this is going to be, my second term is 1 over 1 factorial times x minus 0 to the first. For my third term, I need to know second derivative, which is e to the x, and the value when I plug 0 in, my center in, is still 1. So this is now going to be 1 over 2 factorial times x minus 0 squared. For my fourth term, I need to know my third derivative, which is still just e to the x, and the value when I plug my center in is still 1. So this is going to be plus 1 over 3 factorial times x minus 0 to the third. And if I do a fourth term just to be sure, because I think I see a pattern here, that's again e to the x, and when I plug in 0 to that, I still get 1. So I'm going to have plus 1 over 4 factorial times x minus 0 to the fourth. And as this keeps going, what it looks like my general term is going to be is 1 over, so this is over 0 factorial, which we define as 1 over 1 factorial, 2 factorial, 3 factorial. So I see it's 1 over, it looks like n factorial times, well, x minus 0 is just x raised to the n power. So my Taylor series here would be the sum for n going from 0 to infinity of 1 over n factorial times x to the n. And this, then, is my series that is equivalent to e to the x when I'm centered at 0. And we'll worry later about the interval of convergence for this. A second example I could do here, still using e to the x, but this time I'm going to center it at 2. So again, I need the function, and I need some derivatives so I can start figuring out the values at the center for these. And I'm just going to do these quickly here because we already figured out all these derivatives. And then I'm going to need to know the values. Oops, made my mistake there. I need to know the values at the center, which in this case is 2 and not 0, for all of these. Well, because the derivatives and the function are all the same, when I plug 2 in, I get e squared for all of these. And I will say, normally when I'm doing constructing a Taylor series, I do all of these first and then start putting it all together. So my first term is just f of my center, so e squared. For my second term, it's the derivative at the center over 1 factorial times x minus the center to the first. For my next term, it's second derivative at the center over 2 factorial times x minus the center squared. And for my fourth term, I use the third derivative at the center over 3 factorial times x minus the center cubed. And just doing another one just because I think I see a pattern, but I want to be sure. So what I'm noticing here is I have e squared every single time. This would really be over 0 factorial, which we define as 1. So over 0, 1, 2, 3, 4 factorial. So it's looking like I'm going to have e squared over n factorial. And then I have an x minus 2 raised to the n. So my series would be the sum from 0 to infinity of e squared over n factorial times x minus 2 to the n.